Hello, this is Pooja Bhardwaj and I'm going to present a brief presentation on ruby laser. These are the contents which are going to be discussed. Introduction. A ruby laser is a solid-state laser that employs a synthetic ruby crystal as its gain medium. The first ruby laser was developed by Dr. T.H. Mayman at Hughes Research Laboratories in 1960. The ruby mineral is aluminum oxide with a small amount, about 0.05% of chromium, which gives it its characteristic pink or red color by absorbing green and blue light. The ruby laser is used as a pulsed laser, producing red light at 694.3 nanometer. After receiving a pumping flash from the flash tube, the laser light emerges for as long as the excited atoms persist in the ruby rod, this which is typically about a millisecond. Construction. A ruby laser consists of three important elements, that is laser medium, the pump source and the optical resonator. Now what are they? The laser medium. In a ruby laser, a single crystal of ruby in the form of cylinder acts as a laser medium or active medium. The pump source. The pump source is the element of a ruby laser system that provides energy to the laser medium. In a ruby laser, population inversion is required to achieve laser emission. Population inversion is the process of achieving the greater population of higher energy state than the lower energy state. In order to achieve population inversion, we need to supply energy to the laser medium, and here we use flash tube as the energy source. And the optical resonator, the ends of the cylindrical ruby rod are flat and parallel. The cylindrical ruby rod is placed between two mirrors. One mirror will reflect the light completely, whereas the other will reflect most part of the light but allows a small portion of light through it to produce output laser light. In a ruby laser, a ruby crystal is formed into a cylinder. The cylinder is surrounded by a high intensity lamp to provide a white light which triggers the laser action. Working. The ruby laser is a three-level solid-state laser, as shown in the figure. In the ruby laser, optical pumping technique is used to supply energy to the laser medium. Considering a ruby laser medium consisting of three energy levels E1, E2 and E3 and n number of electrons as shown, we assume that the energy levels E3 is greater than E2 and E2 is greater than E1. The energy level E1 is known as the ground state or lower energy state. The energy level E2 is known as the metastable state, and the energy level E3 is known as the pump state. Now let us assume that initially most of the electrons are in the lower energy state, that is E1, and only a tiny number of electrons are in the excited states, that is E2 and E3. When light energy is supplied to the laser medium, the electrons in the lower energy state gains enough energy and jumps into the pump state, that is E3. The lifetime of pump state E3 is very small, that is 10 to the power minus 8 seconds, so the electrons in the pump state do not stay for long period. After a short period, they fall into the metastable state by releasing radiation-less energy. The lifetime of metastable state E2 is 10 to the power minus 3 seconds, which is much greater than the lifetime of pump state E3. Therefore, the electrons reach E2 much faster than they leave E2. This results in an increase in the number of electrons in the metastable state E2, and hence population inversion is achieved. After some period, the electrons in the metastable state E2 falls into the lower energy state E1 by releasing energy in the form of photons. This is called spontaneous emission of radiation. When the emitted photons interacts with the electrons, In the metastable state, it forcefully makes them that electron fall into the ground state, that is E1. As a result, two photons are emitted. This is called stimulated emission of radiation. When these emitted photons again interact with the metastable state electrons, then four photons are produced. Because of this continuous interaction with the electrons, millions of photons are produced. In an active medium process, a process called spontaneous emission produces light. The light produced within the laser medium will bounce back and forth between the two mirrors. This stimulates other electrons to fall into the ground state by releasing light energy. This is called stimulated emission. Likewise, millions of electrons are stimulated to emit light. Thus, the light gain is achieved. The amplified light escapes through the partially reflecting mirror to produce laser light. Now the applications. Ruby laser has very high output power of the order of 10 to the power 4 to 10 to the power 6 watts. It has wavelength of 6943 angstroms. Laser metal working systems for drilling holes in hard materials. High power systems for frequency doubling into the UV spectrum. High brightness holographic camera systems with long coherent length. Medical laser systems for tattoo removal and cosmetic dermatology. High power Q switched system. Now here are the drawbacks. As the terminus of laser action is the ground state, it is difficult to maintain the population inversion. This fact results in ruby laser's low efficiency. The ruby laser requires high power pumping source. The laser output is not continuous but occurs in the form of pulses of microsecond duration. The defects due to crystalline imperfection are also present in ruby laser. Now the conclusion. The first laser to be operated successfully was ruby laser. First demonstration of laser action using ruby crystal was given by Dr. T. H. Mayman on May 16, 1960. Ruby lasers have declined in use with the discovery of better lasing media. They are still used in a number of applications where short pulses of red light are required. And now these are the references. Thank you.